Welcome to problem number 37, the last one from the August 2016 Algebra Regents exam. It's a pretty involved question. There's a lot going on and a lot of questions to answer. Now, let's get started. So, for the class picnic, two teachers went to the same store to purchase drinks. One teacher purchased 18 juice boxes and 32 bottles of water and spent $19.92. The other teacher purchased 14 juice boxes and 26 bottles of water and spent $15.76. The first question we need to answer is to write a system of equations to represent the costs of a juice box, J, and a bottle of water, W. Let's get started. Now, we know that each juice box costs J. So for the first teacher, they bought 18 juice boxes. We'd multiply those two together. Plus, we'd add in 32 bottles of water that cost a W amount. And we know the total of those is going to be $19.92. And similarly, the other teacher purchased 14 juice boxes. We'll get 14J plus 26 bottles of water, so 26 times W. And they spent a total of $15.76. So, first part of the question is done. We've got our system of equations here. Now, next up, Kara said that the juice boxes might have cost 52 cents each, and that the bottles of water might have cost 33 cents each. What we need to do is use the system of equations to justify that Kara's prices are not possible. In order to do this, what we're going to do is replace J, the price of each juice box, with 52, and we'll replace the W, the price of water, with 33 cents. And what we're going to do is we're going to see if one of these equations is in fact true. And because we already know it's not possible, we'll probably get proof that it doesn't work out. So let's go ahead and try it with this second equation here. I'm going to replace juice with... Now, you might think we're going to replace it with 52, but we're talking about 52 cents, and everything else is in terms of dollars. So this is very important that we replace it with 0.52, because that's, in terms of dollars, that's what 52 cents looks like. Okay, then we're going to add 26 times the price of the water, which is 33 cents, and that'll be 0.33. And what we're going to do is find out if this, in fact, is equal to 15.76. 14 times 0.52 gets us 7.28, and 26 times 0.33 is 8.58. And if we add these together, we get, 15.86. And just as I had predicted, these two are not equal to each other. Therefore, we've proven that these prices are not possible. Ooh, sorry for my messy writing. Okay. Now we're moving on to the final part, the third part of this problem. And what we need to do is solve the system of equations to determine the actual cost in dollars of each juice box. And I apologize that the rest of the question got cut off, but we need to find the price of each juice box and the price of the water as well, the water bottles. Since I'm running out of room, we're going to zoom in a bit here. Okay, so I just went ahead and rewrote the two equations that we figured out. Now, to solve the system of equations, we've got two methods. We could try substitution or elimination. It looks like both methods are going to be quite difficult here. If we tried to isolate one of the variables, it would be quite complicated. And also, if we tried substitution, in order to do elimination, we need either the j's from both equations or the w's from both to have the same coefficient. And I think that's what I'm going to try here. I'm not 100% sure what the lowest common multiple is of 14 and 18. But there is one way to figure that out, and that's to use prime factorization. Let's do that over on the side here. I know that the multiples of 18 are 2 and 9 is 3 times 3. And then if we compare that to 14, the factors of 14 are just 2 and 7. Now, to find the lowest common multiple, what we're going to do is we're going to pick these 3 prime factors, multiply them together, and then add in any other additional factors from this number. Since we've already used a 2, I'm going to take that one out, but we haven't used a 7 yet. By multiplying these 4 numbers together, we get the lowest common multiple, which is 126. So that's what we want our coefficients in front of the j, in the j terms, to become. Now, in order for 14 or 18 to become 126, we need to multiply everything by 7. So times 7. And then for 14 to become 126, we're going to need to multiply this whole equation by 9. Alright, now let's write out what these become. So the first one, we're going to get 126j, and then 32 times 7 is 224, and 1992 times 7 is 139.44. Now the second equation, we're multiplying everything by 9, and we're going to get 126j plus 234w equals 141.84. Okay, now that we have both j's with the same coefficient, we can subtract the second equation from the first one, making these j's cancel out. And what we'll be left with is, well, actually, you know what, we're going to subtract it the opposite way just to keep everything positive. So 234 minus 224 will get us 10w, and then 141.84 minus 139.44 is 2.4. And then to isolate w, we're going to divide by 10, and we'll get w equals 0.24, or 24 cents. Great. Almost done. Now we just need to solve for j, the juice amount. And we can do that by going back to one of the original equations and replacing w with our solution, 0.24. Okay, and this equals 1992. Alright, 32 times 0.24 is 7.68. Just write everything else out here. Then we're going to subtract 7.68 on both sides, canceling out, and we get 18j equals 12.24. And finally, we would divide both of these by 18. Sorry, I'm kind of running out of room here. This is a long question. Okay, canceling those out, and we'd be left with the price of each juice box being $0.68. Okay, that was quite a question. Hopefully all that made sense to you. And that is everything for this video. Thanks very much for watching. JD's Regents Preparation.